Hey y'all, let's finish up the lecture for exponential functions. This is the second and last video for this piece. The other video is covering up through this point. Now, this is also how my class usually I try to separate it as well to where it gives you a chance to actually go through and fill out this information before class. If you have not had the chance, please make sure, or if you missed the last class, that you watch the other video and attempt this before I do it. This is the you tries, and if you have a you try, I really want you to attempt these before I do it. So if you please pause the video if you have not done this already, complete it on your own piece of paper, or if you printed off the guided notes, which is great because you have that $50 credit. Then you come back and watch the video to see if what you did is exactly what I did. This is not the time to actually learn the information. I mean, it is, but my lecture has covered this. So this is just to make sure that the notes that you've already taken, that you can use those to complete the rest of this. All right, so pause, do this, and then come back and watch me play. All right, given the three statements below, identify which represents exponential functions. Now, up to this point, I've always told you that percents are representative of exponential functions and constant rates of change are representative of linear functions. So there can also be things that you may not think of as being necessarily exponential because they do not have the percentage in there, but they also are going to be exponential functions. So on the exam, on your homework, make sure that you understand that you check to see if something's not necessarily a whole, even if it's a whole number, make sure that you verify it's not exponential growth. So the cost of a living allowance for state employees increases by 3.1% each year. So the growth is a percentage, so this has got to be exponential. Okay. The value of an investment is increasing by $300 each year. This is increasing by a specific number every year. So that is linear. All right. Tuition costs have increased by 2.8% each year. It's increasing by a percentage, so this is exponential. Okay. There are other words that can be used for exponential, doubling, tripling, different things like that as well. Looking at the following two equations that represent the balance in two different savings accounts, which account is growing faster and which account will have a higher balance after 3 years? Okay, well, the growth is based on percentage. All right, so we need to know what these percentages are for the growth, not looking at anything else other than what's inside the parentheses. So for A, the growth is what? Well, we know it's growth, and because it's growth, I'm going to write this down. Because we know it's growth, we're going to take the number that's inside the parenthesis and subtract 1 from it. Once we get that, we change it to a percent by multiplying by 100, and we see that that's 5% growth. Right? Now I'm going to take B and do the same thing. 1.075 subtract 1 times 100 is 7.5%. So for the questions, and since these are questions, we have to represent in sentence form, which account is growing faster? So account B is growing faster. Answer the question. I didn't ask by how much, but that's always good too. And which account will have a higher balance after 3 years? Okay. I'm not sure if we've done this up to this point because my mind's just a little foggy on that, but I don't believe we have. So this is going to be a learning piece for you. And in this, we're just going to use where T is and plug in 3 because T is always representative of years. So I'm going to take A of T. I'm just going to rewrite it over here because I don't have enough space. Is 1,000 times 1.05 to the T. B of T is, where's it at? There it is, 900. They start with 900, and they have 1.075 to the T. So, oh, y'all can't see that. There we go. I just rewrote them so that I could work and show you how to do this. So they're asking us at 3 years, so that means t is 3, what is the value? So I'm going to do the same thing for both, b of 3, and then I'm going to just use the calculator. All right, on your calculator, you're going to type in 1,000 times, open parenthesis, actually, you're going to need the times. Hold on. 1,000, parenthesis, 1.05, close parenthesis, caret, remember you may have x to the y, y to the x, x to the box, caret 3 equals. All right, and I'm going to do that on mine. So 1,000, parenthesis, 1.05, close, caret 3 equals. Is a 1,157.625. 1,157.625. Cool. All right, let's do the other one. 900 caret 1.075 close. I'm sorry, goodness gracious. You would think I'm losing my mind today. 900 open parenthesis 1.075 close parenthesis caret 3 equals. Let's try this one. My goodness, y'all. 900 open parenthesis 1.075 close parenthesis caret 3 equals. Is 1,118 point a bunch. I'm gonna write it all down. 1118.067188. All right. If you were not able to get these numbers based on putting it in just as I did, you probably have a TI-30XA or a Casio or something different. All right, so if you have a TI-30XA calculator, you're gonna have to put the multiplication sign in between the number and the parentheses. Only the TI-30XAs. If you have a Casio, we're gonna have to manipulate it to figure out how that one works, because all I know is my TIs very well. All right, so let's answer this question, because this is actually a sentence form question. It asks us which account will have a higher balance after 3 years. All right, so who has the higher balance, A or B? All right, well, A does. A has a higher balance. But there's a couple more things I want to talk to you about this. First, neither one of these are being representative of money in the United States. In Estados Unidos, we have to always round. Our rounding digit is always, always, always in money our hundredths place, because our smallest coin is the penny. So we have to represent the penny. Sorry, having a little fun. So my rounding digit is 2, which means my test digit is 5. My test digit is 5 or greater. So I'm going to add 1 to my rounding digit. All right. And when I do that, I get that my account A after 3 years is, I'm going to make sure my dollar sign's there, $1,157.63. Okay. My account B after 3 years, I'm going to make sure my dollar sign's there just to represent what's happening, is 1,118. There's a comma there. And my rounding digit is 6. My test digit is 7. So 7 is 5 or greater. So I'm going to add 1 to my rounding digit and get 0.07. So that's only just in case I ask you, so hey, who's larger, or who has a higher amount in the account after 3 years? And then I can also ask you by how much, because that's something I would want to know. So that's why I wanted to make sure that you had this, so that you could always say by how much. So just understand, if you're dealing with American money, you have to round to the hundredths place. So the final answer for this is, question was, which account will have a higher balance after 3 years? Account B, account A will have a higher balance. If I were to ask you by how much, you would just subtract them. And then you could say by $ and the amount. All right. So the next piece of this is complete the table. The first one's been done for you. So you've got your example here. They provide a function. Well, this is exactly what we did in class. Initial value, growth, decay, and there's the rate. So initial value for this one is 500. Growth, because it's greater than 1. And to find out how much, remember with growth, you have to take the amount that's in the box inside the parentheses and subtract 1 from it. So 1.03 minus 1 is 0.03. And then we're going to change that to a percentage by multiplying it by 100, and we get 3%. You multiply by 100, and then you add the cute little percent sign just to represent percent. All right, so that is a 3% growth. The next one is our initial value is 3,200. It is growth as well because it is greater than 1. And then the rate is we're going to take the 1.2, just like that last one. We're going to subtract 1 from it and then multiply by 100 and add the percent sign. So this is a 20% growth. All right, next one is initial value is 19,611, and it is decay because the number inside the parentheses is less than 1. And then for decay, it's different from growth. It's not the number in the parentheses minus 1. For decay, it's 1 minus the number inside the parentheses, which is 0.98. So I get 0.02. I'm going to take the decimal, change it to a percent, and I get 2%. So for this one, it is decaying at 2%. The last one, they're actually wanting us to create functions. All right, so our initial value is 50 for the first one. It is growing. So what you need to understand is f of x is equal to a 1 plus or minus r to the x. For growth, it is the 1 plus r. So I'm going to take that percent, change it to a decimal. So 12% divided by 100 is 0.12. That's going to be my r. So I'm going to take the 1 plus r and put 1 plus the 0.12. And I get 1.12. All right. And then you're just going to have that raised to the x, because we haven't learned anything else about the x yet. The next one, the initial value is 377. And then we need to figure out what's inside the parentheses. It's decay. So with decay, you're going to use 1 minus r. 1 minus r is decay. So 1 minus the percent in a decimal form. It's 8%. Change it to a decimal, 0.08 by dividing by 100. So plug that right here. 1 minus 0.08 is 0.92. And that goes inside the parentheses. All right, that's for creating that. All right, in the year 2021, India's population was 1.408 billion, growing at a rate of 8.7% per year. So it's growing exponentially. Write an exponential function for India's population. On my exam, I am not going to tell you to write an exponential function. You're going to have to know that this is an exponential growth and that you're going to have to write an exponential function. I'm going to tell you to write an equation or write a function to represent India's population. Just to let you know, not to expect me to tell you which type of function you're dealing with here. That's part of what you need to understand from this lecture and doing the homework. All right, so we know it's exponential because it's growing at a percentage. That's how I know that. So I'm going to use f of x, my exponential function, a 1 plus or minus r to the x. All right. We're going to use f of x it's going to be called India's population. We need to to understand what each of these things are. This is the initial amount of the population, initial population. And it's growing, so we're only going to use the positive, the plus. And then the rate, we need to understand what the rate is. The rate is 8.7%, but we need to change that to a decimal. which would be 8.7 divided by 100 is 0.087. All right, and then the last thing is we're going to have the X. So I'm going to say India's population is, the initial population is 1.408 billion times 1 plus 0.087 to the X. Okay. Here's where Mom and I disagree. Mom is my open math, and they will accept this answer. I will not. If you can do anything regarding the order of operations in a problem and you choose to not do that, I'm going to take a point off for each time you do that. Don't leave money on the table. Get all the points you can. So this is a 1 plus a number. Have it. That's all you got to do. Give me this. Whenever I ask for you an equation from you, just add those two numbers. Not hard. Just do it, because otherwise I'm going to take a point off your exam, just to let you know. Use the function. So we're going to use the function we just created to predict the population in 2050. Well, how the hell are we going to do that? We need to know how to do that. In order to do that, we need to know what the initial population was and when it happened. The initial population was 1.408, and it happened when? 2021. So this is how far in advance of that. That's taking 2050 and subtracting 2021. And we get 29 years. So we're saying 29 years after, when this equation is legit, what is the population? So that means I need to take the X and plug in 29 to the 29th. In your calculator, unless you have a TI-30XA or a Casio or something, you're going to plug in, I'm going to show you exactly, 1.408 caret, or you might have y to the x or x to the y or x to the box. Sorry, I'm so sorry. 1.408, open parenthesis, 1.087, close parenthesis, caret, or y to the x or x to the y or y to the box, I'm not sure what they have. And then you're going to put in 29 equals. Put that into your calculator. If it doesn't work, then you have either a TI-30XA or you have a Casio or one of those. And a TI-30XA, you need to put a multiplication sign here. All right, everyone else should not have to. So let's check to see what this is and make sure we all get the same number. 1.408 parenthesis 1.087 close parenthesis caret 29 equals. So we got that the population is going to be 15.8219. Let's go that far. So let's write this down. 15.82192. 15.821929. It keeps going. I'm just going to stop right there. Because they gave us the population up to the thousands. You want to at least represent through the thousands, sometimes even through the 10,000, tenths, what is it, tenths, hundreds, thousands, up to the 10,000s, just to, CYA, just to make sure you got everybody covered. I'm just going to round to the same as what they gave us, and my test digit will be the next number over. So since my test digit is greater than 5 or 5 or greater, I'm going to add 1 to my rounding digit. So I'm going to say the population in 2050, you can say for India will be, or should be, or whatever you want to say, will be, and I'm going to say 15.822, but then I've got to come up here and say billion, because otherwise you're saying there's only 15 people. That's so wrong. All right, let's keep going. If you have any questions about that, let me know. All right, example 18. Bismuth-210 is an isotope that radioactively decays by about 13% each day, meaning that 13% of the remaining bismuth-210 transforms into another atom polonium-210 in this case each day. I need you to understand all this chemistry stuff. I need you to understand the percentages and how to write the formula. So if you begin initial value with 100 milligrams of bismuth 210, how much remains after 1 week? So let's start it. If we have it, well, first of all, we need to know if it's a linear exponential function. I know it's exponential because it's a percentage that it's changing each day. All right, so I'm going to use this to create my linear function, just so that I can answer the question. It didn't ask me to write a linear function, but I need one in order to calculate what's happening here. Okay, so I'm going to say this is the remaining, f of x is the remaining bismuth, 210 bismuth. All right, and A is the initial amount. R is the rate in decimal form. And X is the number of, well, in this case, I normally say X is a representation of years. But in this case, the change is happening each day. So X has to be how often it's changing. So the X has to be the number of days. Okay. When we get to finance, it's going to be every year, but X can be a representation of, it's just our time, all right, that it's changing. So I can start with f of x is equal to my initial amount. You begin with 210 milligrams, with 100 milligrams times 1. Now, is it growing or is it decaying? They told us that it's decaying. So minus the rate, and how fast is it decaying? 13%. So I need to change that to a decimal and plug that in here, per day. All right, I'm not leaving it in this form just because you'll already know that I want you to clean it up. Granted, I didn't ask you to write an equation, but you don't want to put in 1 minus 0.13. That's just one more step in your calculator. You have a chance of messing up. Don't do that. All right, now we know from the initial value of 100, it's decaying at 0.87 and per day. And they're wanting us to know how much remains after 1 week. So we're not going to plug a 1 in here because it's decaying per day. So I need to know how many days are in a week. And I know that there are 7 days is equal to 1 week. All right. So f of 7 is 100 times 0.87 to the 7. Show you how to put that in your calculator. 100, open parenthesis, 0.87, close parenthesis, caret 7, and equals. Show you how that looks. 100, open parenthesis, 0.87, close parenthesis, caret 7 days, and equals. So they're starting off with 100 of the 100 milligrams of the bismuth 210. They now have, after 7 days, 37.725. I'm going to write that down. 37.725. All right, now we need to write a sentence. They had it in the whole numbers, so I guess we could have the whole numbers, but let's talk about that. If we're going to say that we're decaying, and if I wanted to answer this as a whole number, I would have to round this up to 38 because this would be my rounding digit. This would be my test digit. This would become 38. But this is decaying. So it's starting off with this much and it's dropping down. So starting off with 100, it's dropping down. It's now past having 38 milligrams. It no longer has 38 milligrams. So we can't say that it has 38 milligrams. We could say it has 37 because it definitely has that. But just to make it a little bit clearer, I'm going to say that they have 37.7. I'm going to use this one as my rounding digit. And I'm going to use this as the 2 as my test digit. So there remains 37.7 milligrams, get those units in there, of bismuth 210 after 1 week? Just answer the question. How much of bismuth 210 remains after 1 week? The sentence, there remains, got my sentence. I've got my rounding, even though I didn't tell you what to round to. I explained what my rationality was. And then I've got my units. So I've got everything I need to make sure I got my point. All right, the next one. I'm going to pause for just a moment. I'll be right back, y'all. Okay, let's go to example 19. An investment is initially worth $10,000. Write a formula for the value of the investment for each situation below. So now we're going to add some new things to our exponents. Up to this point, our exponents for our exponential functions have been just x, or just the change that's been happening, how often, the time-wise. We're still dealing with time in our exponents, but now we have to understand that everything we do in our exponents is based on year. What happened over 1 year? And that's what's going to be my driving force for this. So, and I'm going to show you each one of these. If you have just these, along with my explanations of other ones that we can use, this will help guide you through your homework to know what to do in your exponents. So if I say the value increases, that means I have growth because I'm dealing with percent. All right. So I'm going to just write this on a separate sheet of paper so that we have this same information. Give me just 1 minute. Just so that you can see what I'm doing. All right. So an investment's worth 10,000. I'm going to use f of x is equal to a 1 plus or minus r to the x. All right. And for this, my A is my initial value, 10,000. And that's going to be the same for all of these. All right. I'm going to do A, B, and C. F of X is 10,000, which is the initial for all. 1, 2, 3. Parenthesis, parenthesis, parenthesis. 1 plus, they told us we're growing. 1 plus, and we're growing, or increases, by 5%. Well, 5% changed to a decimal is 5% divided by 100 is 0.05. So 0.05. They're all the same up to this point. So right now, I'm just going to leave it as we've got an X, an X, and an X. This is what it would normally look like. 2, 3, 1.05. F of X is equal to 10,000, just cleaning it up, 1.05. I don't want to put the X's there yet. And then F of X is 10,000, 2, 3, 1.05. Now let's talk exponents. If I were to just put an X up here, that means that the increases, the value increases every year. Every year is always going to be your variable X, or whatever they're using, T for time or whatever. The value increases every 3 years. That's not based on 1 year. That's based on 3. So if it's 3 years, that means I need to take my X and divide it by 3 to get this down to what's happening on a 1 year basis. So if it says every blank years, you're going to go X divided by whatever that blank is. Okay, for your exponent. This is only in your exponent. So it's going to be X divided by 3 in your exponent. All right. The next one says every 6 months. Well, that happens how many times per year? Again, this is all based on a 1 year time. So if it happens every 6 months, 6 months happens twice a year. So that means the value increases by 5% twice a year. So we're going to have to put 2x in our exponent. Okay. So for this one, it's just going to be x because it's every year. This one, the exponent is going to be x divided by 3 because it happens every 3 years. And then this one is going to have to be 2x in the exponent because it happens twice a year. Again, everything is based off of a 1 year model. Okay. So let's go to example 20. consider the following situations and write a formula for each of these situations using time in years as the input quantity. The population of a town was, it's going to be our initial value, 83.6 thousand in the year 2005, and grew, so we have growth at a rate of 11.5% every year. I'm going to use f of x is equal to a, parenthesis 1 plus or minus r to the x as my basis for creating this. So they just want our formula. So f of x is going to be our population. The initial value, a, is 83.6. I'm going to open my parenthesis, and it's going to be 1, and they're telling us that it's growing, so it's plus our rate. Our rate is 11.5%. 11.5% divided by 100 is 0.115. Now, we're so used to just putting x in that exponent. We're not doing that anymore. Okay, we've moved to the next piece of this, which is every 8 years. And you're going to want this on your note card. Every blank years means in that exponent, you're going to be putting that x divided by that blank. So every 8 years, I'm going to put in my exponent x divided by 8. I'm going to clean this up because I told you you're going to want to make sure all of your order of operations are complete before you give me your final answer for these. Do not think just because it works for mom, it's going to work for me, not your mom. All right, x divided by 8. So there is my final answer that I'm going to be turning in for my exam. I'm just going to put a box around it so that I get full credit. All right. Please make sure you let me know if you have any questions on this. The next one, the company sales were 14.2. There's my initial value, million, at the beginning of 2011, and have been decreasing, so that's decay, at a rate of 3.2% per quarter. I'm going to use my exponential function formula because I'm decaying at a percentage. So f of x is going to be my sales is equal to the initial value of 14.2. Inside my parenthesis, it's decaying, so it's 1 minus the rate, and the rate is 3.2%. Divide by 100, and I get 0.032. All right. And then my exponent is per quarter. How many quarters are in 1 year? There are 4 quarters in 1 year, so it's 4x. Final answer for this one is f of x is equal to 14.2 times, I don't know what that is. Let's clear this out. 1 minus 0.032 is 0.968. I'm going to write that whole thing in there. Do not round, please. That's not a big enough number to round. And then 4x for my exponent. Okay, I want to talk about, first of all, this is if you're given every blank years, you're going to want x divided by whatever that blank is in your exponent. That's the easiest one, all right? It's when you get to the point where you need to know how many things happen in a year that the struggle is real. So I want to talk about a couple of those. And we're strictly dealing with exponents here. What's happening in exponents? So if they say that it's happening twice a year, or let's say we can say twice a year per year. I'm trying to think of those different things. Semi-annually, annually. What did they use up here? There was another one that they used. Oh, every 6 months. Every 6 months. These are all going to be in your exponent at 2 times the variable. Okay, those are all going to be 2x. All right, if it is quarterly, quarterly means it's going to be a 4x in the exponent. Every what can we say here? Every 3 months. That too would be quarterly. Every 4 months. That would be 3x. I don't think there's anything else we could think of. Daily? What if it was daily? It would be 365x. Weekly, because I haven't shown my useful conversions, that would be 52x. Monthly, oh my gosh, we could get crazy with this. Monthly would be 12x. Daily, weekly, monthly, quarterly. I think I've covered most of them. So these are all good things to have in your arsenal of being able to handle these situations, to understand what would need to be in the exponent. These are all what would be in the exponent to represent how often it's happening per year. Okay. Let's move on. So that being said, I want you to pause my video and attempt these on your own, then come back and check yourself. So you've got your notes for what we just did. Take those notes, pause my video, work through this, and then come back, okay? Just to give yourself that opportunity. And then I'll help you through it right now. An investment is initially worth $84,300. Write a formula for the function v of t, representing the value of this investment after t years, this is going to be my exponent, in each of the following situations. So instead of f of x, we're going to use v of t. So just instead of f of x, I'm going to go ahead and use v of t is equal to, I'm going to use a for my initial value, and then 1 plus or minus r raised to my exponent for my exponential functions. Exponential functions. All right, we just need to make sure they're exponential. All right, so the value increases by 6.5% every year. So that's exponential because it's a percent. So I'm going to write exponential so I don't mess that up. So A is V of t. Initial value is 84,300. And it's increasing, so that's growth. All right, so I'm going to use the plus. 1 plus, my rate is 6.5%. 6.5 divided by 100 is 0.065. And it's every year, so that's just X. I'm going to clean it up so I don't lose any points on this. V of t is equal to 84,300. 1.065 to the X. There's my answer for that one. The value decreases by 3% every year. This is also exponential because it's a percentage. So V of t is equal to 84,300. So it's exponential, but it's decay. All right, so that's going to be a 1 minus the rate, and the rate is 3% divided by 100 to change it to a decimal. 1 is 0.03 raised to the every year. So it too is X. Clean this up. .97 to the X, and there's my answer for B. All right, let's look at C. The value increases by $600 every year. Hold up, no percentages there. That's a specific, that's an actual amount. It is increasing every year. That's not exponential growth. That's linear because it's increasing by a specific amount every year. So this is linear. We're going to have to use our linear functions. And it's increasing. So I'm going to use f of x is equal to, remember, it's a1. Is this what I did for linear functions? No, I'm so sorry. F of x is equal to b plus or minus mx for a linear function. All right, so for this one, I have to use my v of t instead of f of x. And I know my b, which is my initial value, is 84,300. And we are increasing, so it's plus, and then it's increasing by 600 per year. And that should be a t. Oh, this should be a t as well. These should all be t's. Okay, t, 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 and t. That's the problem with doing that. But this is not an exponent. This is down here with the 600. So there is my linear function for C. And let's go to D. I'm going to do that on a different page because I'm running out of space here. All right, Let's do that. And for D is the value decreases by $1,400 per year. That too is linear and it's decreasing. So I'm going to use f of x is equal to b plus or minus mx. Again, just make sure you have your linear functions. So minus v of t is equal to the initial value of 84,300. It's decreasing, so it's minus, decreasing at $1,400 per year. Okay, so there is my linear function for D. Two more, we've got E. Value increases by 26%. We're back to exponential again. And it's every 2 years and it's increasing, so it's growth. And then you've got this bad boy right here that's going to make our exponents look different. So I'm going to go back and use my v of t is equal to a 1 plus or minus r to the t. So v of t for this one, the initial value is 84,300. 1 increasing, so it's plus. The rate is 26%. So 26% divided by 100 is 0.26. And we're going to raise that to the, not just t, but it's every 2 years. And I told you, if you have an every blank years, that's going to be t or x divided by blank. For this case, it's going to be t in the exponent divided by 2 years. Cleaning that up, 84,300, 1.26, the t divided by 2. Final answer. All right, last one is F. All right. So I'm going to get some to the paper. All right, F is same thing. It's exponential as well because it's 13%. It's decay, so exponential decay. So my v of t is equal to the initial value of 84,300, and then it's 1 minus r because it's decay. 1 minus the percent. 13% changed to a decimal by 100 is 0.13. And then my exponent has to represent that this is decaying every stinking month. So how many times does month happen in a year? 12 times t. Clean this up. V of t is equal to 84,300 times 0.87 raised to the 12 t. Final answer. Okay. All right. And that's it. That finishes the lecture. There's only one more thing I kind of want to say about this that I would do in class is I would go through and say, okay, what would the value be after blank years? So for each one of these, I would say, okay, what would the value be for each of these after, say, 5 years? And just to make sure you have this support system, I'm going to do it for every stinking one of them. All right. So if for A, my formula, my function was V of t is equal to 84,300 times 1.065 to the t. I'm going to write each one of these with the 5 for the years, and then I'm going to do them with the calculator. The thing I want you to do is make sure that you can get the same value that I do on these as we go through and do it. So for A, I'm going to put in my calculator 84,300, parenthesis 1.065, close parenthesis, caret 5, and equals. So for A, I would get 84,300, open 1.065, close caret 5 equals. So the value would be $115,498.3057. Let's talk about this. So I got 115,498.3057. If you were to answer this question, because I would ask you, what would the value be after 5 years? I'm going to write that down. What will the value be after 5 years? And I'm going to use this for every stinking one of them. So with that question, I have to answer with a sentence, correct units, correct rounding. Those are the big dogs. Don't lose points on this. Don't leave money on the table. So to answer the question, the value will be blank in 5 years. That's how I'm going to answer it. So to find my value, I need to know what my unit is. This is dollars that we're talking about here. And because it's dollars in Estados Unidos, in the United States, we always round to the penny. That's my rounding digit. My test digit has to be the number to the right. It is 5 or greater, so I have to add 1 to my rounding digit. So my answer is $115,498.31. Okay. If you didn't get that, please touch base with me so I can make sure and get you there. The next one, the function for V of T is 84,300 and 0.97. So this was decaying per year because the value that's T up in the exponent numerator. All right, so I'm going to plug in 5 for T to see what the value is going to be. I'm not worried so much about you being able to plug in the values for these. It's the ones that have the different exponents that I'm worried about. So please, if you understand this and you're getting the right ones, great. Please go all the way through till you get to those last two, just to make sure your exponents are right, because there's some tricky stuff on there I need to show you with the calculator. So for this one, the value will be, I'm going to use the same words, $ in 5 years. All right. Plugging this in, it should be 84,300, parentheses, 0.97, close parentheses, caret 5, and equals. All right, let's do that. 84,300, open, 0.97, close, caret 5 equals. So it's decaying. Therefore, it's no longer worth 84,300. It's now worth 72,391. Point what? So let's start with the 70. I've got my $, 72,391. No one's arguing about that. Point 2, I need to know what my ones place is. Because I'm rounding to my rounding digit is 7, my test digit is 8. 8 is greater than 5. Therefore, I'm adding 1 to that 7. All right, there's B. C, what will the value be after 5 years if V of T is equal to 84,300? This one was the linear function growth and was growing at 600 per year. All right, so we're plugging it in to see what it's going to be worth in 5 years. So everywhere there's a T, I'm just going to plug in a 5. To put this in your calculator, I'm going to clean this up a little bit. I'm going to multiply these two. 84,300 plus, looks like 3,000 is 87,300. All right, so the value will be $ 87,300, no rounding needed, in 5 years. Got my sentence, got my unit, I'm golden. Let's go to D. D was f of x. So, it's V of T. V of T is equal to 84,300. This one was linear as well. And it was decreasing at $1,400 per year. So we have to find out what the value is in 5 years. 1,400 times 5. Just going to 1,400 times 5. I'm going to do my order of operations here. Is 7,000. So 84,300 minus 7,000. And so I'm going to take 84,300 minus 7,000 equals. So the value will be 77,300. The value will be $ 77,300 in 5 years. All right, 2 more. And these are the ones that I worry about for y'all. All right, that was D. We need E. Here it is. E's value. What will the value be in 5 years? So V of T, and this is back to the exponential again, 84,300 times 1.26 raised to the T. Pardon me, the T divided by 2 in the exponent. All right, here's the one. V of 5. what's the value in 5 years? 84,300 times 1.26 raised to the 5 divided by 2. Okay, to keep from messing up, I'm going to give you exactly how to put this into your calculator, just as it is right now. All right, you've got some options, but one of the things I'm going to tell you not to do is to divide this first. If you do, it's fine as long as it's a nice clean number. But if it's a number that is one third, if you put 1 divided by 3 in your calculator and you see it's 0.3333333 forever and ever, amen, you can't just put 0.3 up here. You can't do that. You've got to put the 1 divided by 3. So I want to show you how to put this in your calculator with the fraction and the exponent. In your calculator, you're going to type 84300, just like it is, open a parenthesis, 1.26, close parenthesis, caret, or whatever your exponent button is, open another parenthesis, 5 divided by 2, close parenthesis, equals. That's how you're going to put that in your calculator. All right. So feel free to do it along with me. 84,300, open parenthesis, 1.26, close parenthesis, caret, open parenthesis, 5 divided by 2, close parenthesis, equals. So the value after 5 years will be worth $150,229. And, well, our rounding digit is the first 5 here. Our test digit is the second 5, which is 5 or greater. So we have to add 1 to our rounding digit. So this 5 right here becomes a 6. So the value will be $150,229.06 after 5 years. There's my answer. Okay, the next one is F. F is V of T is equal to 84,300, 1.26, this one's growing, every 2 years. We want to know what it is after 5. So 84,300, 1.26 raised to the, oh, I already did this one. Oh, I'm doing E again. I'm so sorry, y'all. Let me go find F. Oh, here it is. No one told me. All right, so V of T, I know you're yelling at the screen right now, is 84,300. Let's try this again, y'all. And it's 0.87 to the 12 times 5. Well, it's T, 12T. So V of 5 is 84,300, 0.87 to the 12 times 5. There we go. All right, let me show you how to put this in your calculator. 84,300, open parenthesis, 0.87, close parenthesis, caret, open parenthesis, 12 times 5, close parenthesis, equals. Okay, that's what you're going to be doing. Could you have multiplied this first? Heck yeah. Yeah, you could have just put 60 and then you would have had just put 60 in here. But again, mistakes. Be careful with the mistakes. So let's do this. I'm going to put it exactly as it is. I find that if you put it all in at once, y'all make fewer mistakes than if you go through and do the piecemeals, especially if you're not comfortable with order of operations. So I'm going to type in 84,300 and get used to doing things like this, because when we get to the finance section of this class, you're going to put it all in at once. I beg of you to do that. So open parenthesis, 0.87, close parenthesis, caret, open parenthesis, 12 times 5, close parenthesis, equals. One more thing. A lot of y'all ask me, do you need to put the 0 in here? You don't need to, but you can. It doesn't change anything. Okay. So you could put 0.87. All right. So your answer is, it started off with a value of 84,300. Now the value after 5 years is only 19.6 0.81448, whatever this means. So we're dealing with dollars here. So we went from $84,300 to the value is, or will be, and it's $19.80 what? Rounding digit is 1, test digit is 4, test digit is below 5, so we leave the 1 alone. So $19.81 after 5 years. And there's my answer. If you have any questions, let me know. Have a great one.